So after spending time figuring out what makes triangles congruent, we want to take the next step now. So we have 4 congruent shortcuts that we remember. We remember side, side, side. We remember side, angle, side. We remember angle, side, angle. And we remember angle, angle, side. So those are our 4 methods to prove triangles congruent. So today, we want to go past this. We want to say things that are true about the other parts of the triangles. For example, if I know side, side, side is true, what it means is that the 3 sides of one triangle are congruent to the 3 sides of the other triangle. It means that the triangles are congruent. But what's true about the angles of those triangles? That's what we want to talk about today. And it's a really big thing. It's like bigger than a conjecture. It's more powerful than a locomotive. It's that if 2 triangles are congruent, then the corresponding parts of those congruent triangles are congruent. So here's what that means. What it means here is that if I've got 2 congruent triangles, so let's say I have like triangle ABC, and I know that it's going to be congruent to triangle DEF. And let's say I do it congruent by side, side, side. So I got that, 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 I got that. I got all those things congruent. Great. So I know my triangles are congruent. What it means is that corresponding parts, like angle A, corresponds with angle D. So since the triangles were congruent by side, 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 it means that angle A has to be congruent to angle D. They're corresponding parts. They're the same parts that are in the different triangles. Angle A matches up with angle D. They're corresponding parts. So what it means is that if you have congruent triangles, the corresponding parts of those congruent triangles are congruent. And yeah, that is so wordy. I'm wondering, do you think we can come up with an abbreviation for this? I don't know. What are we thinking about? Yeah, we abbreviate this Cpctc. Corresponding parts of congruent triangles are congruent. It's a very, very big relationship in geometry. Let me show you how it's used. So what we want to do is we want to write a little paragraph explaining why this is true. We're going to do a little paragraph proof, if you will. So when we start these explanations, what we're going to write down is we're going to write down what we're given first. So let's say we're given that BE is congruent to CE. Whoop, that E has one too many tails on it. And we're given that angle C is congruent to angle B. So, like we did before to figure out what makes triangles congruent, let's mark up our diagram. BE is congruent to CE, and angle C is congruent to angle B. All right, this is a bow tie diagram. It kind of looks like a bow tie. Remember, in a bow tie diagram, we're going to get a pair of vertical angles that are congruent. So what I'll do is I'll say, by the vertical angle conjecture, let's say what's true. Angle AEB is congruent to angle DEC. So again, we're going to say why it's congruent, and we'll say what's congruent, and we'll justify it with a reason, like a conjecture. And again, bow tie diagrams, you want to look for those. So now, as I look at my figures, I have angle, side, angle. So I'm going to say that by ASA, let's say that triangle ABE is congruent to triangle DCE. Now, here's where our new thing comes in, our Cpctc. Because I don't just want to say that the triangles are congruent, but what I want to say is, are these 2 parts of those triangles congruent? So side AB is along the top here, side CD is on the bottom. Think about if I kind of spun the bottom triangle around, it would land on top of triangle ABC, so that side AB would land on top of side CD. So I'm going to then say that by Cpctc, AB is congruent to DC. This explanation is good. This is a proof. We've proven why it's true. We've written a nice little explanation, or kind of like a funny kind of paragraph as to why it's true. Well, let's keep going. Let's try one more together. And again, we're doing two things here. We're talking about Cpctc, but we're also talking about triangle proofs, a big concept in math. So again, I got some given information, so let's write that down. We're given that angle CDB is congruent to angle BEC. Let's mark that down. Angle CDB congruent to angle BEC. And we're also given that angle EBC, that little angle there, congruent to angle DCB. Boy, this diagram is getting really wacky. So if you have colored pens or pencils, it's pretty helpful to trace over them. So it looks like these two triangles are going to be triangles BDC. This triangle here, that kind of looks like that, BDC. And it looks like this red triangle here too. You remember from doing the triangle congruency that sometimes if these triangles overlap, it's good to separate them a little bit. So then we have side ECB, and in those, I have these two angles congruent and these two angles congruent. All righty. Well, do you see that both triangles share side BC? So let's write by shared side that the BC in the green triangle is congruent to the CB in the red triangle. And can you tell how I did that ordering? It looks like if I go from B to C, I'm going from an angle that's not marked to an angle that's marked with a little slash mark. So if I do the same thing in the other side, I should call it CB. If you called it BC, it's okay, but hey, we're trying to do things the right way here. So because of that now, it looks like I have an angle-angle side relationship. So let's say by angle-angle side, triangle BCD, the green one, is congruent to triangle CBE, the red one. And again, by Cpctc, hey, do you remember what that means? No looking back. Corresponding parts of congruent triangles are congruent. I know that side CE is congruent to side BD. So two things here. We want to write up a type of a paragraph style proof, and we also want to use that Cpctc to say why things are congruent. Hope you enjoyed it as much as I did.